Earlier, we spoke about the training, evaluation, and deployment phases of model development. And you might think, well, there aren't any more phases, so what else is there to know? Well, there are some issues that don't map well to phases, and many of them are very important. So in this section, we will review general best practices and best practices related to pursuing AI responsibly. Usually, you don't build only one model. Instead, you do a lot of experiments. For example, you would try creating a machine learning model to predict demand for bicycles in two ways. One way with weather data and the other without weather data. Does the error decrease when you add weather data? If so, weather is important as an input feature. You might experiment with different ways of dealing with the station ID. You might try training a single model for all the bicycles in the city. You might also try training separate models for commuter stations and inner city ones. And then you will choose a better approach. Even though machine learning models are standard, you can often control the complexity of those models. For example, you can control how many layers you have in your neural network. More layers create a more complex model. So, you would try a neural network with 3 layers, another with 4 layers, and then choose a network that works better. Typically, you start with simple models and slowly increase the complexity. I said you need to choose the approach that works better. Choose the better model. Works better on what? You have to compare whether or not to use weather data, whether or not to train separate bicycle station models, whether to use 4 layers or 5 layers by looking at evaluation metrics on a part of the data that you did not use for training. The problem is that with all this experimentation, you are starting to make decisions based on the data that you're evaluating against. So, you shouldn't use the test data to select input features or limit model complexity. BigQuery ML and AutoML both know this, and they handle this for you automatically. If you give them 80% of your data for training, they won't use all 80% for training. Instead, they retain a small portion of it for model selection. So the numbers that you get when you do the experiments, they're based on an independent part of your training data. You don't need to touch your test data at all. So you can use the evaluation metrics reported by BigQuery and by AutoML to do all of your experiments. So this is one of the many ways that machine learning on Google Cloud helps you do the right thing. Okay, I'm a bit biased. Another best practice in machine learning is to do pilot projects. Don't be satisfied with dry evaluation metrics like root mean squared or precision or accuracy or recall. What really matters is the impact on the things that your users care about. So, show the model predictions to your end users. And by that I mean actual predictions on individual examples. Again, we saw this with AutoML. Remember that the evaluation page showed you the classification for selected images, the places where the model was correct and where the model didn't do very well.